What if everything you thought you knew about the universe was missing a piece? Imagine looking up at the night sky, seeing all those glittering stars, and thinking you understand your place among them. But what if, hidden in plain sight, there are enormous regions of space so empty, so vast that they make the night sky look crowded by comparison? These are not science fiction dreams, they're real, and astonishingly, we live right next to one. Welcome to the story of cosmic voids, the enormous holes in the universe, where galaxies are few and far between, and matter is stretched thin across millions of light years. Picture it like a desert in the middle of a sprawling city. Streets are empty, buildings are rare, and yet life continues around it as normal. That's our cosmic neighborhood. And what makes it even more mind-bending is that, even inside these colossal emptinesses, the rules of physics, gravity, light, time, carry on exactly as they do elsewhere. There's no magic, no time warps, no hidden portals. Just sheer scale and the quiet hum of the universe doing what it always does. In this video, we're going to take a journey into that emptiness. We'll uncover what cosmic voids are, why they exist, and how they shape the motion of galaxies, even the Milky Way itself. We'll explore how scientists discovered these regions, how they map them, and the subtle ways these giant cosmic deserts influence our universe. And along the way, we'll challenge the way you see the cosmos, because emptiness, it turns out, is far more fascinating than it first appears. So stay with me, and by the end of this journey, you'll never look at the night sky the same way again. You'll realize that even in the quietest, emptiest corners of space, there's a story unfolding on a scale so vast, it almost defies comprehension, and we're living right next door. The cosmic web. When we imagine the universe, it's easy to picture galaxies scattered randomly, like glitter thrown into a dark room, but the reality is far more structured and far more beautiful. Galaxies are not placed at random. On the largest scales, the universe has an architecture, a pattern that stretches across billions of light years. Astronomers call it the cosmic web. This web is made of matter pulled together by gravity over cosmic time, forming an enormous network that gives the universe its large-scale shape. Ever wonder why some parts of the sky feel crowded with galaxies, while others look strangely empty? That unevenness is the first clue that the universe is woven together in a vast, invisible design. At the smallest level of this structure, individual galaxies gather into groups and clusters, bound together by gravity. These clusters don't sit alone. They connect to one another through enormous filaments, long, thread-like structures made of galaxies, gas, and dark matter. These filaments stretch for hundreds of millions of light years, forming the scaffolding of the universe. Where many filaments intersect, massive clusters form, some containing thousands of galaxies. Between these dense regions lie walls of galaxies, thin but vast sheets that trace the boundaries of something even more astonishing. And then there are the voids. Imagine a sponge floating in space. The solid parts of the sponge are the filaments and clusters, dense with matter. The holes in the sponge are the cosmic voids, immense regions where galaxies are rare and matter is spread extremely thin. These voids can span tens to hundreds of millions of light years across. They are not mistakes or gaps. They are a natural outcome of gravity pulling matter inward, leaving behind enormous pockets of emptiness. The cosmic web is defined just as much by what's missing as by what's there. This isn't speculation or artistic imagination. Scientists have mapped this structure using massive galaxy surveys, the most famous being the Sloan Digital Sky Survey. By measuring the positions and distances of millions of galaxies, astronomers have been able to reconstruct the three-dimensional structure of the universe. When these maps are visualized, the cosmic web appears unmistakably: filaments, walls, clusters, and vast voids, all revealed in stunning detail. It's one of the strongest pieces of evidence that the universe has a large-scale order, even though it may look chaotic at first glance. What are cosmic voids? Cosmic voids are some of the largest structures in the universe, yet they are defined by what they lack. These regions are vast expanses of space where galaxies are incredibly sparse compared to the cosmic average. While clusters and filaments shine with billions of stars, voids appear almost empty, stretching across unimaginable distances. They are not small gaps between galaxies, but enormous regions that can span anywhere from about 20 million to more than 150 million light years across. To put that scale into perspective, light itself would need tens of millions of years just to cross one of these cosmic deserts. Despite their name, cosmic voids are not truly empty. They still contain thin clouds of gas, traces of dark matter, and even the occasional lonely galaxy drifting through the darkness. These galaxies are often smaller and less active than those found in dense clusters, shaped by their quiet environment. The matter inside voids is simply far more spread out, making them appear empty when viewed on cosmic scales. This subtle presence of matter is crucial because it confirms that voids are part of the same universe governed by the same physical laws as everything else. So why do these immense empty regions exist at all? The answer lies in gravity and time. In the early universe, matter was distributed almost evenly, with tiny fluctuations in density. Over billions of years, gravity amplified those differences. Slightly denser regions pulled in more matter, growing into filaments and clusters. As matter flowed inward, other regions were gradually drained, becoming emptier and emptier. These areas evolved into cosmic voids, expanding as surrounding structures grew denser. In this way, voids are not failures of structure, but natural consequences of how gravity sculpts the universe. Astronomers don't just theorize about voids, they observe and map them directly. Large galaxy surveys, such as the Sloan Digital Sky Survey, have allowed scientists to chart the positions of millions of galaxies across vast volumes of space. When these maps are analyzed, voids stand out clearly as enormous regions with very few galaxies. By studying their size, shape, and distribution, scientists gain valuable insights into cosmic evolution, dark matter, and even the behavior of dark energy. These are the ultimate cosmic deserts, and astonishingly, we're living right next to one. The local void. On the grand map of the universe, our galaxy does not sit in a perfectly average location. The Milky Way lies near the edge of a region known as the local void, a vast, underdense area of space that stretches across tens of millions of light-years. This region was first identified when astronomers noticed that nearby galaxies were unevenly distributed, with a noticeable absence of galaxies in one direction. Compared to the crowded filaments and clusters around us, the local void stands out as a quieter, more open region of the cosmic landscape. Even so, the local void is not an empty bubble. It still contains diffuse gas, dark matter, and a small number of galaxies scattered throughout its volume. These galaxies are simply more spread out than average, making the region appear emptier when viewed on large scales. In many ways, it's like a low-traffic zone in a vast cosmic city. The roads are still there, and a few buildings remain, but the hustle and bustle of dense galactic neighborhoods is noticeably absent. This relative emptiness has subtle consequences. Because matter is less concentrated inside the local void, surrounding galaxies experience a slight gravitational imbalance. Over time, this contributes to gentle motions as galaxies drift away from the void and toward denser regions nearby. Astronomers have measured these motions and found that the local void plays a small but measurable role in shaping the movement of galaxies in our cosmic neighborhood, including the motion of our local group of galaxies. What's important to understand is that living near a void doesn't mean we're isolated or cut off from the rest of the universe. The Milky Way is still firmly embedded within the cosmic web, connected to nearby filaments and galaxy groups. The local void doesn't disrupt the laws of physics or create anything exotic, it simply adds character to our region of space. And here's the kicker. This quiet neighborhood may hide secrets we're only beginning to understand, offering scientists a unique laboratory for studying how galaxies evolve when left largely undisturbed by their crowded surroundings. Physics inside a void. One of the most common questions people ask when they hear about cosmic voids is whether physics behaves differently inside them. The short and reassuring answer is no. Gravity still works the same way, light still travels at the same speed, time still flows normally, and the overall expansion of the universe continues exactly as predicted by established cosmological models. A void is not a tear in reality or a glitch in the universe. It is simply a region with less matter than average. From the perspective of fundamental physics, a void follows the same rules as a dense cluster of galaxies. There is no observational evidence that cosmic voids produce exotic effects like time loops, energy anomalies, or distortions of physical laws. while voids can expand slightly faster than denser regions due to having less gravitational pull slowing them down. This behavior is fully explained by general relativity. It does not create anything dramatic or dangerous. Scientists have studied light passing through voids, galaxy motions near void boundaries, and the cosmic microwave background itself, and all observations remain consistent with known physics. A helpful way to think about it is like being in a quiet suburb rather than a crowded city center. The rules of life don't change just because fewer people live there. Traffic laws still apply, time still moves forward, and gravity still keeps your feet on the ground. In the same way, living near or inside a cosmic void doesn't alter the fundamental workings of the universe. It's not emptiness that breaks physics, it's extreme conditions like black holes or the very early universe where things become truly strange. What keeps scientists confident about all this is evidence. Decades of observations, simulations, and measurements back up the idea that physics is universal across the cosmos. Large surveys such as the Sloan Digital Sky Survey, along with precise measurements of galaxy flows and background radiation, confirm that voids behave exactly as our best theories predict. So no, being in a cosmic hole doesn't turn you into a time traveler yet, but studying these quiet regions does help scientists test the limits of our understanding and confirm just how consistent the universe really is. How we know we're in the void. So, how do scientists actually know that we live near a cosmic void? The answer comes from one of humanity's greatest detective stories, mapping the universe itself. Astronomers can't travel millions of light years to check what's out there, so instead they read the light arriving at Earth. By observing galaxies and measuring how their light is stretched or redshifted, scientists can determine how far away those galaxies are and how fast they're moving. When millions of these measurements are combined, a three-dimensional map of the universe begins to emerge, revealing patterns that are invisible to the naked eye. This is where galaxy surveys come in. Projects like the Sloan Digital Sky Survey have systematically recorded the positions and distances of millions of galaxies across large portions of the sky. When scientists analyze these maps, they calculate how densely galaxies are packed in different regions. Areas with high concentrations form clusters and filaments, while regions with very low galaxy counts stand out clearly as voids. Think of it like mapping empty streets in a giant city of stars. Some neighborhoods glow with activity, while others are eerily quiet. The local void was identified using exactly these methods. When astronomers examined the distribution of nearby galaxies, they noticed a significant underdensity extending next to our local group. Visual maps showed a vast region with far fewer galaxies than expected, confirming the presence of a void rather than a random gap. Further studies of galaxy motions supported this picture, showing that nearby galaxies subtly drift away from this underdense region toward more crowded areas of the cosmic web. These independent clues all pointed to the same conclusion. The local void is real, measurable, and part of our immediate cosmic environment. What makes this achievement truly remarkable is that all of it is done from a small planet orbiting an average star. Using telescopes, mathematics, and careful observation, scientists have mapped regions of space spanning millions of light years without ever leaving Earth. Every galaxy becomes a clue, every redshift a fingerprint, helping us reconstruct the universe's hidden structure. We can't see voids directly, but through their effects on galaxies and light, we know they're there and we know where we are among them. Cosmic implications. At first glance, cosmic voids might seem insignificant after all. How important can empty space really be? But on the largest scales, voids play a powerful role in shaping how the universe evolves. Because they contain far less matter, gravity pulls less strongly inside them. This means that, over time, voids tend to expand slightly faster than denser regions, while matter continues to flow outward toward filaments and clusters. This contrast between dense and empty regions helps drive the large-scale motion of galaxies and contributes to the overall pattern of cosmic expansion we observe today. Sometimes, emptiness is the most powerful force in the universe. These effects are subtle, but measurable. Astronomers studying galaxy motions have found that galaxies near voids often exhibit coherent flows, gently drifting away from underdense regions and toward more crowded parts of the cosmic web. This behavior doesn't contradict the expansion of the universe, it complements it. Voids act like vast low-pressure zones in the cosmos, influencing how galaxies move without disrupting the fundamental laws of physics. By studying these motions, scientists gain insight into how matter responds to gravity across enormous distances. Cosmic voids also serve as powerful testing grounds for cosmological models because they are relatively simple environments, less crowded and less chaotic than galaxy clusters. They allow scientists to test theories of gravity and cosmic evolution under clean conditions. If our models of the universe are correct, they must accurately predict the size, shape, and distribution of voids seen in galaxy surveys. So far, observations match predictions remarkably well, reinforcing confidence in the current understanding of how the universe evolved from its early, nearly uniform state to the complex structure we see today. There is also cautious excitement about what voids might reveal in the future. Some researchers study voids to probe the nature of dark energy, the mysterious force driving the accelerated expansion of the universe, because voids are especially sensitive to its effects. Others examine how dark matter behaves in these underdense regions, where its influence is less masked by ordinary matter. While no radical conclusions have been proven yet, voids offer a unique cosmic laboratory, quiet, vast, and revealing. Empty spaces shape the fate of the universe in ways we're only beginning to understand. Common myths and misconceptions. One of the biggest misconceptions about cosmic voids is the idea that they are completely empty, like holes punched out of the universe. In reality, voids still contain matter, just much less of it. Thin gas, dark matter, and even a handful of galaxies exist inside these regions, spread across enormous volumes of space. They appear empty only when compared to dense clusters packed with galaxies. On cosmic scales, almost empty and truly empty are very different things, and observations consistently confirm that voids are part of the same continuous universe, not gaps in it. Another popular myth is that physics somehow breaks down inside a void. Movies and online speculation often suggest strange effects like warped time, altered gravity, or violations of physical laws, but every observation tells a much calmer story. General relativity works just as well inside voids as it does anywhere else. Light bends normally, gravity behaves predictably, and time flows at the same steady pace. Voids are quieter environments, not broken ones, and they provide strong evidence that the laws of physics are universal across the cosmos. There's also a fear that living near or inside a void might be dangerous, as if our galaxy were at risk of being pulled apart or drifting into nothingness. In reality, we are completely safe. The forces involved are incredibly gentle, acting over millions of light years. Nothing dramatic happens just because a region has fewer galaxies. Life on Earth, the orbit of the Milky Way, and the stability of our local group remain unaffected. And no, you won't float into a cosmic black hole pizza just because space is less crowded. Pop culture loves exaggeration, and emptiness is easy to turn into mystery or danger. But the real story of cosmic voids is far more elegant. They are calm, predictable, and scientifically invaluable. Understanding what voids are not is just as important as understanding what they are. As we come to the end of this journey, take a moment to look back at what we've uncovered. Cosmic voids are not mysterious holes tearing the universe apart, but vast, underdense regions shaped by gravity over billions of years. Our Milky Way lies near one of them, the local void, a quiet neighbor that subtly influences the motion of galaxies without changing the fundamental laws of physics. Inside these immense spaces, gravity still works, light still travels faithfully, and time continues its steady flow. The universe remains consistent, elegant, and deeply ordered, even where it appears almost empty. What makes this realization so powerful is the sense of wonder it restores. We often associate meaning with things that are bright, loud, or massive, but the universe tells a different story. Even emptiness has meaning. The voids help shape the cosmic web, guide the motion of galaxies, and offer scientists some of the clearest environments for testing our understanding of dark matter and dark energy. In their silence, voids speak volumes about how the universe formed and where it may be headed next. Now, imagine the impossible for a moment. What would it be like to travel through a cosmic void? No crowded skies filled with galaxies, no glowing clusters nearby, just vast stretches of darkness, broken occasionally by a distant island of stars. It wouldn't be dangerous or strange in a physical sense, but it would be profoundly humbling, a reminder of scale, a reminder of how small we are and how extraordinary it is that we can understand any of this at all from a tiny planet orbiting an average star. If this journey sparked your curiosity, take a moment to be part of it. Like the video if it made you think, share it with someone who loves space as much as you do, and leave a comment what surprised you the most, or what part of the universe do you want to explore next, because the story doesn't end here. Next time you look at the night sky, remember, some of the most fascinating places in the universe are the emptiest,